Okay, so we're in the second video relating to Workshop 1, Geoprocessing Analysis. And in this part of the exercise, what I'm going to do is introduce our data and then work through the process of our analysis. And in most of these videos, again, I'm going to remind you of what I think are best practices in terms of setting up your environment in the ArcMap situation. So what I've got here is I've opened up an ArcMap document. I've named it Week 1 Workshop. And I'm going to do a few other quick things. First of all, remember always in terms of my map document properties that I'm going to title it, and again, Week 1 Workshop. I'm going to leave the rest of it blank for right now. I want to change my default Geodatabase from, again, the default in here to a working directory. And I'm going to choose my results as my directory, my default Geodatabase, because that's something I'll move along with me when I'm done with my analysis. So I'm going to click Add to that. And then remember, I'm going to store relative path names. I'm going to apply that. And so we're at least at the starting point. Now the next thing I want to do is, because I'm going to be doing distance analysis, I'm going to need to be working with projected data. And so the first thing I want to do is make my first data frame consistent with the coordinate system that I want to use. Now again, we're doing distance analysis, so I'm going to be using projected data. And because I'm within the state of Pennsylvania and I'm interested in meters, remember I had talked about having a 100-meter buffer, I'm going to choose a UTM coordinate system based on NAD 83. Pennsylvania's in zone 17 north, so that's what I'm going to pick here. And so again, once I've done that, click OK. Now you'll notice that immediately I now have my meters in terms of my coordinate system. The next thing I'm going to do is I've moved all of my data into a Geodatabase. Some of the shapefiles I've converted into those, but I left them in their original coordinate system. And what I want to do now is go through a process of making them all the same projection. And so what I'm going to do here is I'm going to use the batch project option. So I'm going to click on that, batch project, and I'm going to go to my folder. And again, this is my data folder. You'll notice that I have all of these files. I'm going to select all of them. And then my output workspace, okay, I'm going to move these into, for the moment, into my results. Here, I'm going to produce a new Geodatabase. And in this case, I want to have this one. You'll notice where I started was Week 1 data. And I'm going to create a new Geodatabase that I'm going to say is the same name, Week 1 data. And for me, I like to tell in my naming conventions what the data is. So in this case, it's Week 1 data, but it's the UTM NAD 83 coordinate system. So that's where I'm going to write all of this to. And so again, that's where it's going to go out to. We're going to want to make sure that my new Geodatabase we can use. Make sure that's the right one. Now, my output coordinate system. This is where I want to go into this and say that everything that's going to be written is going to end up as UTM NAD 83. And remember again, we're in zone 17 north because we're in Pennsylvania. So, and in this case, I'm not going to use any transformations because we're looking at some different types of data here. I'm going to click OK. And again, because we're only interested in coarse analysis, we're not interested in a vertical datum in this case, and I'm not going to focus on the transformations. It is important to note that those transformations would matter significantly if we were looking at more precise data, and in fact, we were doing this for a real company. So I'm going to click OK. And we'll let the batch projection run. Now we have all of the layers converted to UTM zone 17 north, and what I've done is I've added a number of them, and I want to kind of begin to understand how we're going to work through each of the data sets. what you'll notice here, and I'm going to turn off everything except for the state boundary and our trout streams, is now everything is in here. The data frame is set to UTM zone 17 north, and in this case all of our data sets are also, if you'll notice when we look at their general information and their source, that you'll notice that all of them are also NAD 83 UTM zone 17 north. So all of our data, and if I were to open all these, you'd see that that is the case in each and every one of them. We now have data that's in projected coordinate systems, and so we can begin to manipulate our data. Now remember that the first thing I said was that we wanted to deal only with Mercer and Butler County. Now, of course, there are two ways of going at this process. One approach is, and again, here is our counties layer, and again, I've made it hollow. We're interested in Mercer County here and Butler County here. So that'd be one geometry or geography that we want to deal with. And one approach to limiting our data would be, of course, to right-click on the counties file and go to Properties and use a definition query to state that we are interested in the counties whose name is equal to, and we're interested in Butler, or, remember this is a Boolean logic, so the name can either be Butler or, in this case, name, and again, remember we have to have the field, and equals to, and in this case, and remember we can also use the go-to, and I'm going to look for Mercer, and I'm going to do this, and I'm going to do this a couple different ways, and you'll see the comparison of these. So option A, when I don't need to change geometry, is to use a definition query, and you'll notice that now I have those two counties. I've used a definition query to constrain the data. Now what I haven't done is changed that feature class, because again I can go back now and in properties I can clear that definition query and all of the data is still there. Now the alternative to this is in fact part of our extraction option. I can use the select tool here, and in this case what I will do is it's essentially the similar process. My input feature again is my PA counties. My output feature class, and I'm going to write this to my week 1 results, is going to be, again, we're going to go into my week 1 working and into my results, which is my default location. And in this case, I'm going to say Mercer Butler. That's what I'm going to name the output. So my input is all of my counties. My output is going to be those two counties, and in this case I'm going to use an SQL expression, and it's going to be essentially the same expression that I had used in my definition query. So in this case I'm going to say name is equal to, and again I'm going to get my unique values here because I want to make sure that I put it in right, Butler, or again name is equal to, and again we can use our go-to, and we're going to use Mercer. So now again I've said this, but the difference here is that what the select does is it actually creates a new feature class that contains the definition. So let's use that one. I'm going to hit OK, and in this case I'm going to then apply the tool, and the tool will run, and you'll notice that now I have a new feature class that is just those two counties. That's the select tool. So select doesn't change necessarily what we're going to have. Now what I want to do is I'm going to do the same thing to the municipalities. And again, I want to think about when I don't have to cut or break geometries, I'm going to be using a select tool, or I'm going to use a definition query. And the reason for that is that if I were to try to clip the municipalities by the counties, it is possible to produce sliver polygons. In other words, if they are not perfectly co-registered, some of the edges might be affected. So again, we're going to do a similar process, because you'll notice here now I have my counties, Mercer and Butler, so I don't need this one anymore, so I'm going to get rid of that. And the next step that I'm going to do is I'm going to do the same task on my municipalities. And you'll notice that the county municipalities are very, very extensive. And again, I want only those municipalities that are within the 2 counties. So again, what I'm going to do is we're going to use our select option. And my input features now are going to be my municipalities. And my output is going to be, again, I'm going to just type this in, and I'm going to shorten it to Butler, Mercer, Muni. Now again, my expression in this case, I have to do it a little bit differently. We're going to use county is equal to, and we're going to get our unique values. Now this is a little tricky. You have to know the county value within the state, or, and because I know these two, I'm going to use this. Rather than using county, I'm going to use its FIPS code. So the FIPS code for the counties that I'm interested in, the FIPS county that I'm interested in is going to be equal to, and I'm going to get the unique values again. And what we have is Butler is FIPS code 19, or FIPS county is equal to, and in this case 085 is Mercer. And so now I'm going to say that, and again what I'm going to do here is OK. And the same thing is going to happen in that I'm going to get back out only those municipalities that are within the county. So again, I've used the select when these are co-occurrent geometries. So again, I'm going to get rid of the overall PA municipalities. And now I have my 2 layers, my Butler and Mercer County and my Butler and Mercer County polygons. So municipalities and the counties. Now where we change this is when we go to the clipping option. I'm going to add the HUC boundaries now. I'm going to turn off my Trout stock streams for just a moment so you can kind of see what's going on. And at this moment I'm going to turn these hollow so that we can kind of see what's going on. And I'm going to turn this one off for the moment. And what you'll notice is that these 2 areas are all of the HUC 12, that is the small watersheds that I'm interested in. But because their geometries do not co-occur, I'm going to use a clipping option to get the new geometries of only the HUCs that are within it. Now, that's very different from a select option. So if you'll notice here, I could select by location, and this, I'm going to show you the 2 different outcomes from this. If I select by location the HUC 12s that co-occur with my counties, and you'll notice here I can say intersect. And again, later on we'll talk a little bit about all of the options. We could have, of course, have intersect, are within a distance, or completely contain. But for right now we're going to use intersect, and I'm going to apply that. You'll notice that what I actually get are all of the HUCs that touch in any way those 2 counties. So I get a much larger area. And if those were, in other words, if I wanted that interaction between them, then what I would do, and I'm going to actually do it right now, is I would right click and I would export those selected features, and in this case what I'm going to call them, we're going to put these into the results data set. Okay, but you'll notice we have these 2, and right now I'm going to call these HUC intersect. And it's going to ask me, and I'm going to add them back in, and now I'm going to turn off my selections, and you'll notice that I get all of those. Alternatively, if I only want what is co-occurrent with Butler and Mercer County, I'm going to have to use my clip option. And so here's the clip option. I'm going to use that, and my input, again, in this case, is going to be my counties. Now, I could clip it by the municipalities, but in this case what I really want to do is I want to clip it by the county boundaries. So any 2 features can be used for this, but again, I'm going to input, and again what we want to do is when we talk about this, our clip feature is what is used to clip. The clip is the cookie cutter. The input is, in a sense, the dough. So again, we want first our huck, and in this case I'm actually going to use our subset. It works a little bit easier. Well, no, we'll use the regular one. We'll use full. And then I'm going to clip it again by Butler and Mercer County. Now, what I'm going to put in my results is the huck is what is going to be what we're interested in. So we're going to say huck clip, and again in this case Butler Mercer County. And so we're going to do that. You're going to hit OK. Now I'm going to turn off these other two options, and you'll begin to see what in fact we got out. Okay, so again, let me turn off all of this, and now we have just the portions of the hucks that fall within that county area. Okay, so again, we've changed the geometry. It is also important to note that because we've changed geometry, we've changed, and if you'll notice, if I go to my hucks, I'm going to open up very quickly their attribute table, you'll notice that because these are feature classes, they have a shape length and shape area calculated. Now, what is important also to note is that if we consider these, those that have been cut, they're going to have a different area, and their area will be recalculated. That's another important factor about clipping using feature classes. Areas are recalculated. Okay, so now we've clipped that. So our first tool set is the idea that we can say we want to cut pieces out, and we're going to use clip or select to extract information out. Now, split, I will say, I just want to briefly show what split does. We're not going to use it in this exercise, but split is designed so that if you have a gridded system, and for example, I'm going to add this right now, this is a grid that covers all of Pennsylvania. If I were to use my toolbox and select split, what it would actually do is, in a sense, do a clipping of the entire data set, but rather than clipping only within a certain feature, it would actually divide all the data into each of these tiles. And so splitting is a way to tile data based on a tile template, which I have right here. And again, we'll be using that in another exercise later on. All right, so that's it for the first one, and again, these are our extract options. In the next two videos, we're going to be talking about the other ways of geoprocessing as we move forward.